Okay guys, so I'm just going to work through this review really quickly. If you end up needing more help over it, come in and see me, of course, and because some of this stuff I am going to kind of go quickly through it, okay? So just to kick it off, okay, number one, evaluate each of the integrals. So for number one, it looks like we have, looks like I have lost connection actually. Hold on just a second. See if I can figure this out. Come on, pen. There we go. Okay, so for number one, letter choice A, we're doing the integral of the square root of x minus 2x all over x to the third. Okay, we don't have a quotient rule, so you can't do this as is. You're going to have to rewrite it as x to the 1/2 over x cubed minus 2x over x cubed. With one term in the denominator, you can totally split this up, and that's how you need to approach it. When you simplify exponents, you subtract, so this becomes x to the, let's see, 1/2 minus 3 would be negative 5 halves, I think. Let's see. Woo. Okay, minus, because that would be minus 6 halves, so yeah, negative 5 halves minus 2x to the negative second, and this is where we're going to take an integral, okay? So I need to add 1 to this exponent, so that's going to be x to the negative 3/2 times a negative 2/3. Remember that little trick I showed you in one of the prior videos? And then minus, this is going to be x to the negative first, because we're adding 1 over a negative 1, which will make that a positive. And then plus c. The only cleaning up I would do is to shoot the x's back down to the denominator because they are negative, but that should be your answer. Okay, great. So moving on to letter choice B. That one is the integral of the secant times the secant plus the tangent. Okay, this also looks weird initially, but maybe if you thought, I don't know what else to do, maybe you thought to distribute, and that's a good thought, because then it turns into secant squared plus the integral of secant tangent. And why is this good? Well, because we're supposed to have these memorized. The integral of secant squared is tangent. The integral of secant tangent is secant. And that's it. You're done. Okay? Next. Alright, next are a bunch of approximations. So for number 2, when we have f of x is x squared plus 1, we're going to set up a right-hand sum with 3 partitions that go over the interval 0 to 1. So if I'm splitting up 0 to 1 into 3 partitions, it looks like they're going to be split up for the every 1/3, okay? And so if I'm doing a right-hand sum, then that means that I will be doing little rectangles that are 1/3 in width. So all 3 of them have a width of 1/3, so I'm going to just factor that out to the front. And if I'm focused on the right of each of those, so if I just kind of do an x-axis here, and this is 0, and that's 1/3, and that's 2/3, and then that's 1. A right-hand sum means I need to first go to the far right. I'll be pulling from this f value. So it'll be f of 1, then I'll draw a rectangle. Then right here, I'll draw a rectangle off the next one, and then my third rectangle will come from f of 1/3. So that should be, that's it. That's my answer. It says I don't have to evaluate, so I'm done. On B, identical question, but now we're coming at it with a left-hand sum, okay? And so if I'm pulling from the left, the far left of this means I now start at 0 instead of starting at f of 1. So it'll still be 1/3, but it'll be f of 0 plus f of 1/3 plus f of 2/3, and I'll never make it over to that one. The last rectangle ends right here. Letter choice C is a midpoint. So I need to go to all the midpoints of these. So this will be the hardest one to figure out because it's like fraction crazy. So instead of going to f of 0 or f of 1/3, I will need to pull from the middle of those two, which would be f of 1/6. Plus, The next one, that would be 1/6, 2/6. The next one would be 3/6, which is 1/2. That is 4/6, and the next one would be 5/6. So I'm going to all of the little middles of each of those intervals, and I just counted by sixths to help me get over there quickly. All right, so there's letter choice C. And then D is trapezoidal. Same setup. We're going to start with our, in this case, our height for is 1/3. So if you think of area of a trapezoid, it's base 1 plus base 2 times the height divided by 2. Well, if the height is 1/6 and I'm dividing by 2, that's the same thing as multiplying by a 1/2. So I can really just have a 1/6 out front for this whole problem. And then on the inside, I'm just going to be adding up a bunch of base 1s and base 2s. So I'm going to have f of 0 will be my first base 1 all the way over to f of 1/3. That's my first trapezoid. Plus, my second trapezoid will pick up right where I left off and then add over to the next one. Plus, my third trapezoid will pick up right where I left off and add over to the last one. So you can write it like this. If you want to write it as f of 0 plus 2 of these plus 2 of these plus 1 of those, then that's perfectly fine also. Okay, moving on to number 3. Okay, so for number 3, we've got this funky graph that I'm not going to try to recreate, so you'll just have to listen. On this, if it wants the area from 1 to 7, I can just look at my picture because we talked about this means area, and this 1 to 7 are the bounds of the definite integral. So if I look at my picture, I'm just going to chop this into a bunch of different things. I'm going to look at the first one as, I don't even know, maybe we could do a trapezoid and a rectangle and then a couple of other trapezoids in the middle. That's how I'm going to look at it. I'm going to do the first one as a trapezoid of length 1. So here's my h over 2. And then my base 1 is going to be, let's see, 3 plus 1. So there's my first trapezoid. Then I'm going to do a trapezoid from 2 to 3. So the trapezoid from 2 to 3 also has a width of 1. And so we're going to do height over 2. And then the f of 2 is 1. The f of 3 is 2. Okay, so there's my first trapezoid, a second trapezoid. Then I'm going to do a trapezoid from 3 to 4. And so if I go from 3 to 4 on the x-axis, my y values are 2 and 1, okay? And then plus, I've got a rectangle. So that rectangle is 3 units wide with a height of 1. That would be the math that I would do to get my final answer for A, which I'm not actually going to do that right now. You could crank that out yourself. Part B, given a new function, g of x equals this thing above plus 2, it wants to know the same thing except with g of x here. So it's asking for this. So I would do this graphically because when you do a plus 2 at the back of a function, you may remember from pre-cal, I mean that's just a transformation. It means that we're shifting up 2, which means it's going to be the answer for part A. So whatever we get in part A, and then we're going to add an additional rectangle at the bottom that is 2 units taller, and then it's from 1 to 7. So from 1 to 7, so it'll be a rectangle that's 2 times 6, because that'll be a distance of 6 on the x-axis and 2 units taller. So it's the answer to A plus 12. Okay? All right, number 4. For number 4, set up and evaluate a definite integral, blah, blah, blah. Okay, so for this one, it wants you, if you sketch it out, you're going between 1 and 3 and y equals 0. And after you look at your picture, you will realize that it's just a definite integral, x cubed plus 7 dx. That's it, okay? And so once you go to do that, you will take the integral first. Then you're going to plug in the 3 and the 1 and do the fundamental theorem of algebra. We need f of 3 minus f of 1. This is what we talked about in class and in the video. So that just means I need to do 3 to the 4th over 4 plus 7 times 3. Oops, that's a 3. minus, now I plug in a 1. 1 to the 4th over 4 plus 7 times 1. And I'm going to do all of this math. You can group it together like this if it makes you feel better. You're going to math that out and get your final answer, which is posted on the key in class. I'm not going to work that out right now. All right, letter choice B says to do the same thing with x squared minus 5 and y equals 0, which is just the x-axis, okay? So we need to know what this graph looks like first, x squared minus 5x, and I'm already looking at how this factors, so I know it's going to cross at 0 and 5. And there's a vertex or something down here. I don't even know where it is, but you know, we'll do something like that. Okay, so we're looking for this, okay? We want the area bounded by these equations. So it does cross between 0 and 5, and that's really important because that's going to be the bounds on your integrand. So from 0 to 5 are where it crosses, and we're just doing the area. So x squared minus 5x dx. And same thing as just a second ago, we're going to do x cubed over 3 minus 5x squared over 2 from 5 to 0. And once you get that worked out, you'll have your answer. So whatever 5 cubed over 3 minus 5 times 25, okay, another 5 cubed over 2. And then when you plug in zeros, those are going to go away. So whatever that is going to be the answer to your problem. Excellent. Okay, number 5. Okay, for number 5, given the function in the picture, it's already showing you the picture, and it wants you to find the area of the shaded region from 0, shown on the area of 0 to 4. I want y'all to know how to do this in the calculator, and that's why I gave you a calculator picture. So what I'm going to have you do on this one is just look in the calculator at where this is equal to 0, and some of you already see that we can factor. If we do a little bit of factoring like this, then we know it crosses at 0, 4, and negative 4. So that picture has shaded the area between 0 and 4. Even if you didn't look in the calculator, you can look at that on the picture I provided, and we are doing 16x minus x to the third, okay? I want you to be able to do it by hand, but I also want you to be able to do it in a calculator. So if you want on this one to not do it by hand, go to your calculator and type in math 9, and it will give you all of this. You'll just have to fill in the numbers and the function. You'll have to fill in the x, but if you math 9 it, it will give you the integral and find you that area really, really quickly. So that's really nice. Okay, so that's the front side of the sheet. I'm going to make a part 2 video for the back side, so if you need that, you can watch that one instead. Thanks.